All right, so for this problem, it's going to use the idea of half-life, and half-life is the amount of time with something decaying when half of it will be left, right? And so that's what they're giving us is the half-life for this particular substance, radium 226 to decay is 1600 years. And so we have a standard formula that we use, and it is A equals A E K T. And this can be, and this is initial. So this is the amount, and this can be used for exponential growth or exponential decay. This one's going to be decay because we're looking at something that's decaying, but it can also be used with those growth problems, the same formula. The A sub 0 is the initial amount. The A will be the final amount. Even though we're not really going to know those here, we're going to know the percentage. So this is going to be a two-step problem. First, we're going to have to find the K. And what we know is that we always have to divide this out. And since we don't know either of these, but we know that the half-life is going to be 50%. So we're going to divide A divided by A sub 0 is going to be 50%. And we'll go ahead and just use the decimal form of 50%. So 0.50, this is 50%. We will use 0.5 there. This is what we're doing. And that will equal E. And we're looking for K, but we know the T is going to be the 1600 years which they gave us. Right? And so we're going to solve for the K value on this one. Sometimes they give you the K value, but here they did not. So we're going to solve that first. And so we're ready now to take a logarithm of both sides. So we're going to take a log here and a log here. I'll just write it in one step so I can use my red. Right, and that will make this come down. So I have the ln of 0.5 equals K times 1600 ln of E. And this ln of E is equal to 1, so we're not going to need it anymore. And then we're ready to solve for K. We're going to just need to divide on both sides by 1600. And that is going to get us K. So we're ready to go to the calculator with this piece. I'll just rewrite it. Now, we're going to get a number that is in scientific notation, I believe. So, natural log of 0.5 divided by 1600, enter. And we did get it in scientific notation. We don't really want that. We want to switch that over and just have a decimal. So I'm going to write some of that here. Sorry about that. So I have negative 4.33216 9 e to the negative 4. That's what's on my calculator. All right. So this is how scientific notation shows on your calculator. Remember, that is this times 10 to the negative 4. So this means move your decimal 4 places to the left. So here is 1. We're going to need 3 zeros here. Right, and that is probably enough. So 1, 2, 3, 4. I think that's a good enough K value. All right, so that's what we're going to use, and it's negative. Negative. A decay value would always be negative. So our K, which we'll use in the problem, so this is step 1, is negative 0.00043332. Step 1. All right. And now they're telling us that we want to determine how many years. So we're going to look for T, and we want the remains to reduce to 24.4%. So instead of using this A divided by A sub 0 to equal 0.5, we want it to be 24.4. But we should have that as the decimal form of percent, just like this was for 50%. So we'll just move the decimal 2 places to the left. So 0.244. So I'm going to scroll this down so we can keep part of it. So I am going to set up with my 0.244 is going to be, so I have divided out my A equals A sub 0, right? It's going to be this much is left, e to the kt, right? E will still be there. K is now this point, negative 0.00043332. T is what I don't know. And that's what I'll find. So I have a new problem to take a logarithm of. So I'll take the logarithm of both sides. So logarithm here of 0.244. And logarithm over here of e to the negative 0.004332 t. This will come down. So ln of 0.244 equals negative 0.00043332 t times the ln of e, which we don't need because that's equal to 1. And then we're going to divide on both sides by negative 0.00043332. Negative 0.00043332. And that should give our t. This will go into our calculator. So we'll clear just to be careful here. Natural log 0.244, close. I'm going to go ahead and just hit enter. Divided by negative 0.00043332. 3,200.2. Enter. Right, and we're getting 3,256.2, and I think they said round to the nearest whole year. So 3,256.2 is not enough. So this would be years, and we'll just double check. And there we go. So that is our problem. Let me